Hey all, today we're going to talk about similar polygons again, and specifically we're going to talk about similar triangles. And it's going to be similar to what we talked about when we talked about congruent triangles, and we have shortcuts to show that two triangles are similar without knowing all of the information about them. So originally when we talked about similar polygons, we said that all the corresponding angles are congruent. The ratios of corresponding sides are all proportional, so you can write an extended ratio, or I'm sorry, an extended proportion where all the ratios are equal. They simplify to be the same fraction or scale factor. Well, we have these shortcuts, and the first one is the side-side-side similarity, not to be confused with side-side-side congruence. When we're talking about similarity, this little squiggle means similar, much like the little squiggle with the equal sign means congruent. So side-side-side similarity tells us that if we know that extended proportions, so the ratios of all the corresponding sides are equal, then we can conclude the two triangles are similar without knowing anything about the angles. So I'm going to match up these sides. Even though I don't know based on names which sides go together, I can match them by size. So 12 is my smallest side, so is 78. 16 is my next smallest side, then 104, and then the longest side, 20 and 130. So I'm going to write those fractions, and then I'm going to simplify all three of them. They all simplify to be 2 over 13. And so since the ratios of corresponding sides are proportional, my scale factor is 2 over 13. And these two are similar by side-side-side similarity. And then we'll write this similarity statement. Much like we write congruent statements, we need to make sure that the letters correspond to the appropriate angles. So I like to write the first name in alphabetical order, and then I write the second name as it corresponds to this first one. So TU is my smaller side, HG is my smaller side, and then V and F. We can prove two triangles are similar by knowing two pairs of corresponding angles are congruent. We don't even need to know all three, because if we know two of them are the same, then we know the third one must be the same. So here in this triangle, I have angle M is congruent to angle G, and L is congruent to F. And so without knowing anything about the sides, without knowing the third angles are congruent, we know that these two triangles are similar by angle, and we can name them appropriately. Again, I did alphabetical order for LMN, and I saw that L and F have one arc, and M and G have two arcs, and so I named them in this order FGH. And the last shortcut is side-angle-side similarity. It's very similar to side-angle-side congruence, except instead of the corresponding sides being congruent, we have equal ratios. So I'm going to do my smallest side divided by my smallest side, and my bigger side divided by my bigger side, and both of those simplify to be 2 over 3. And then of course right in the middle here we have vertical angles. So we have angles that are congruent in between sides that are proportional, just like side angle side. Those angles have to be included. So we have side angle side similarity. And we can write again triangle similarity statement. So I started with the smaller one, and I went M and Q. And then Q has to be at the end because those are congruent angles. And we'll write MN is sort of going towards the yellow highlighted here, so RS is going towards the yellow highlighted. It's a little bit tricky, but you'll get the hang of it. So let's do a couple here. Let's decide if these triangles are similar. If they are, we need to know which shortcut we used, and then we'll finish the similarity statement that's presented to us. So here I don't know anything about the angles, and so I only have one plane of attack, and that would be side angles, or I mean, sorry, side, side, side. It can't be side, angle, side, because I don't know anything about the angles. It can't be angle, angle. So my possibilities here are side, 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 or that these are not similar triangles. So I'm going to write the ratios of the sides that correspond. So small to small, large to large, middle to middle. And then I'll simplify these fractions if possible. These two I can't simplify. The last one's 3 over 7. None of these are the same. And so these two triangles are not similar. These two triangles over here, I do have one pair of congruent angles. That's shown, 48 and 48, so V and S are congruent. And then I have vertical angles. And so I have two pairs of congruent angles, so these are similar by angle, angle. And then they named the first triangle UVW. UVW, so they went from that vertical angle to the angle that was 48 degrees. So we're going to go from the vertical angle U to SR to name our other triangle. In this triangle, I have vertical angles again, but I don't know anything about the other angles. In each triangle, there's a side I don't know the length of, so side, side, side's not a possibility. Angle, angle's not a possibility. Let's check side, angle, side. These angles are between the sides that are labeled with lengths. So let's check to see if their fractions are, or their ratios are proportional. 5 over 10 and 9 over 18 both make 1/2, and so we have side, angle, side here. And we'll name this other triangle RKL. So RS went across the larger side, so RK goes across the larger side, and that's how we're going to figure out how to name this one. And last but not least, we know nothing about the angles in these two triangles, so let's check side, side, side. All the fractions do simplify to be 8 over 3. And so this is side, side similarity, or side, side, side similarity. And we'll name that smaller triangle EFG. So that's all I have. Make sure that you write down your questions if you have them, so that when we talk in class, you can ask for help.